Hey everyone, what's going on? This is Rob here. Welcome back to the channel, and in this video I'm going to show you how to set up redundant internet service provider connections out to the internet using a Cisco router. So in a previous video I covered this, but that was more along the lines of if you have a business account where all of the IP addressing is static. So it's really easy to just tie your static default route to a tracking object, which is withdrawn from the routing table in the event that the IPSLA monitor fails to get a ICMP echo reply from a well-known address on the internet if that service provider were to have problems. So with the residential account, all that IP addressing information is dynamic because you're going to receive it from a DHCP server. So the configuration is a little bit different, and that's why I wanted to make this video, was to show you the configuration surrounding how to accomplish something like this. So I'm going to take one of these routers in my lab here and essentially just on each of their interfaces simulating redundant ISPs. I'm going to plug into two different VLANs on my production network so that way I can just obtain an IP address via DHCP and then show you how you would set it up. Okay, so let's open up PuTTY and connect to the router. I believe it's COM6. I have two cables connected here to different pieces of equipment in my lab. It might be COM4. Might be COM4. Is it COM4? Is it COM6? It's COM4. Okay, so let's do a show IP interface brief. Okay, we have gig 0/0 and gig 0/1. Both are up and up. Typically, these will be shut down by default, but I did a quick test before I started recording just to make sure that everything was going to work, so I just defaulted the interfaces. So, but otherwise, you would go in there and do a no shutdown. So let's start by entering interface configuration mode on each of these interfaces. And what I'm going to do is I'm going to designate gig 0 as the primary provider and gig 1 as the secondary. We'll go to interface gigabit 0/0. Let's put a description in there just for fun. Put WAN 1. And so being that the ISP connected to, or should I say the ISP, since I kind of faking the scenario by plugging each of these interfaces into two different VLANs on my LAN core switch to simulate two different providers. We are going to sorry, I just I'm losing my train of thought here for a second. Yeah, so anyways, yeah, so gig 0/0 being the primary, first we want to issue the IP DHCP client what is it? Client route track, I believe. Yeah, client route track. Okay, so IP DHCP client route track, and then whatever tracking number we want. So what we're going to be doing is tracking a well-known IP address on the internet to basically see if ISP1 is up or down, and if it goes down, we're going to fail over to ISP2. Kind of like what I showed in one of my videos where I went over how to do this with, like if you have a business account where you're going to be working with static IPs. So the IP addressing is going to be static. Typically, your provider will assign you like a transit subnet and then route your statics to you. And with that being said, you can just create a default route, point it at the IP address of their router on the other end as your default gateway, and then track it that way. So since this is all the addressing information is obtained via DHCP, we have to do it this way. So IP DHCP client route track, and I'm going to say track 3. Okay, you can put whatever it is that you want. It's your choice. So the next step is to give it an IP address. So we'll go IP address DHCP. And so we see that we were assigned via DHCP the IP address of 10.0.14.12 with a /24 subnet mask. Now, we're not actually going to see a default in the routing table at this point because we issued this command up here. So, and we didn't create tracking object 3 yet. We're not tracking anything. So as far as the router is concerned, this is down. There's going to be no static route in the no static default route in the routing table, because once you obtain that information via DHCP, it will automatically stick a static default in the routing table for you. And the reason I chose track 3 is because I'm going to give you a little bit of a bonus. I'm going to track 2 well-known addresses on the internet and show you how to create like an aggregate tracking object to keep track of both of those. And the reason for that is because say you're pinging like Google's DNS server 8.8.8.8. Say that were to go down. I mean, that's going to be pretty rare, but if it did happen, that would take down your primary internet connection, all because of an issue that another service out there was experiencing. So to kind of mitigate that potential issue, I'm going to track 2 addresses and then create an aggregate tracking object. So I'll have track 1, track 2, and the aggregate will be track 3. Now, you don't have to do it this way. Like I said, it's kind of like a little bit of a bonus, but this is the way I'm going to do it for this tutorial. So I'm going to go, actually first I'm going to go IP route quad 0, interface, or not interface, gigabit 0/0, DHCP, and I'm going to assign this an administrative distance of 1. I should have just let DHCP do its magic and showed you before I added that IP DHCP client route track command, because it would have added a static route as the default gateway with an administrative distance of, I believe, 254. So in order to keep this primary, because we haven't configured interface gig 0/1 yet, which will be our second IP or ISP, we want this to have a lower administrative distance, so that way it is the better choice of routes in the routing table, because following the rules of route specificity, it goes prefix length, administrative distance, and then metric. So administrative distance doesn't matter if you have 2 routes and the prefix length is different. So say you had a /27 and then a /24. The /27 will be the more specific route because it has a longer prefix. It's more specific, so that will also be in the routing table. So, but if you have 2 equal routes, so like a default here, quad 0 route, prefix length is the same. So now we're looking at administrative distance. So for the primary ISP, we want to make sure that it is 1. And then the secondary, if this goes down, the secondary will have an administrative distance of 254. Okay. All right, so IP route quad 0, gig 0/0, DHCP, administrative distance of 1. Now I'm going to move on to creating the tracking object that is going to be responsible for determining if this provider is up or down. So we'll start with IP SLA, and I'll give it a number of 1. We'll go ICMP echo, and I'll do 8.8.8.8. Source interface, gig 0/0. I'll do frequency 10. Exit out of that. And then IP SLA, schedule 1, start time now, life forever. And then track 1. So now we want to bind this IP SLA probe to tracking object 1. So I'll go track 1, IP SLA 1, reachability. Okay, now IP SLA. Now, like I said before, if you want to stop here, if you want to just track one address and that be the determining factor, if your primary ISP is up or down, then you could just do this, bind it to the tracking object, and then stick it on this command right here. So we're going to do create a secondary. So I'll go IP SLA 2, ICMP echo, and then I'll say 4.2.2.2. Source interface, gig 0/0, frequency 10. Okay, IP SLA, schedule 2, start time now, life forever. Track 2, IP SLA 2, reachability. Okay, I'll issue a do show track brief. We see we have our 2 IP SLA monitors, which are both down, by the way, and the reason for that is because we don't have a default route. So after I'm done creating this aggregate tracking object, this track 3, I'm going to show you why that is and how we can steer this traffic, these ICMP echo requests, to make sure they go out the interface for ISP1. And the reason we want to do that is, well, for starters, you can see that they're down right now, but we haven't configured ISP2. So if we did, then those ICMP echo requests would go out the interface for ISP2, and it would think that the route was, or the ISP1 was up. It would take that default route, put it back in the routing table, which would then fail again because ISP1, if ISP1 was really down, then it would fail again, which would then cause ISP2 to become, the default route pointing to ISP2 to become active in the routing table. ICMP echoes would go out ISP2, and you know, that route would flat back and forth. So we will be creating a route map to basically tell the router, hey, any ICMP traffic that you're generating, you need to go out gigabit 0/0 for ISP1, and the next hop will be the DHCP default gateway that you receive. Okay, so let's create that aggregate object. So once again, we went up here and issued the DHCP client route track 3 command. So we'll go track 3, whoops, list threshold percentage, and then object 1, object 2. Do show track 3. So track 3, being the aggregate object or tracking object, is going to be looking at 1 and 2. So this needs to be 100% down for track 3 to be down. So say 8.8.8.8 went down for whatever reason, that would only make object 1 down. Object 2 would still be up. So track 3 would remain up. You wouldn't fail over. You would only fail over if there was actually a problem with that service provider and traffic wasn't making its way through. Unless, of course, you had the unlucky event of 8.8.8.8 going down and 4.2.2.2 going down, which is extremely rare. I don't think that's going to happen. And then before I move on, one last thing. Let's go back into track 3 and let's set a delay. we'll say, and you can put this to whatever you want. Sometimes there's going to be a missed ICMP echo reply, and there might be a, now we've kind of like mitigated that by adding 2. So if one doesn't get a reply, the other one will probably still be up. But I still like to put a delay just in case, especially if there's high traffic, a large volume of traffic going through the router. It can cause that to happen. And I've had instances where I've been in the middle of large downloads, and it's caused the, on my network, the providers to switch back and forth from the primary provider in Sprint, which is my backup provider. So you can either QoS that traffic, or you can just implement this delay value to give it some time to work itself out to see if it's really down or not. So we'll go delay down. I'll just go with 20 seconds. On my network, I actually have it set to 40. I think that's fair. Like I said, with large downloads, utilizing a lot of bandwidth for a long amount of time can actually cause this IPSLA monitor to time out quite a few times. So I have mine in my production network set to 40, but 20. I'm just going to use 20 for this example. Again, you can put it to whatever you want. You can play around with it. If you think you have issues, you can change it later. Whatever you want to do. And then for up, I'm also going to put 20 because you want to make sure that the circuit is stable before it comes back up, right? So maybe there's like a brief period of time where you get a reply and it's like, oh, the internet's back. And then it's like, okay, tracking object's back up, route's back in the routing table. And it's like, oh, actually it's not. So again, you could set this to higher. You don't have to put a delay for up, but we'll just do delay down 20, up 20. So it's going to take an additional 20 seconds for this to be declared down. An additional 20 seconds for it to come back up. Do show track brief. Okay, and we're down, down, down. We need to create that route map. So first we need an access control list, an extended one to be specific, because we need to tell the router, hey, any ICMP traffic going to 8.8.8.8 or 4.2.2.2 originating from you need to send out this way, which is gig 0/0 in our case. So we'll go IP access list extended. I'll put RMAP primary ISP. We'll go permit ICMP any to host 8.8.8.8. Permit ICMP any to 4.2.2.2. And I forgot the host. There we go. Do show access list. Okay, access list, RMAP, primary ISP. We have lines 10 and 20 in there. And now we'll move on to sticking that in the route map. So we'll go route map, primary ISP, permit 10. Match IP address. We'll match this access list right here. Match IP address, RMAP, primary ISP. And then set interface gigabit 0/0. Okay. And then set IP next hop dynamic DHCP. Okay. Do show run pipe section route map. So here's our route map. So route map primary ISP permit 10. We want to match this IP address, which is an extended access list that says, hey, any ICMP traffic going to 8.8.8.8 or 4.2.2.2 originating from the route. Well, the route map doesn't say that. We're going to add an IP local policy statement that will say that. So once we do that, it'll say any ICMP traffic coming from the router. We want to set the IP next hop to the dynamic next hop for the default gateway we got via DHCP, and make sure that interface is gig 0/0. Another thing is, you know what? Sometimes I'll do this as well, just to be extra safe that it's not going to go anywhere else. We'll add null 0 to the end as well. So that way if the cable were to come unplugged, well, I guess if that were to happen in this scenario, it wouldn't matter anyways, because even if traffic, ICMP traffic was then going through ISP2 and it would think that was back up, it wouldn't come back up because the interface would be down. But either way, let's put the null 0 there to be safe. Better safe than sorry, right? Okay, and then now we're going to apply this to the, apply it to the control plane of the router, I guess. So IP local policy route map, and then primary ISP. Now, as soon as we apply this, we should have our tracking objects come up. I was going a little slow there for a second, so I'm thinking like, I think they should come up. And now we have that delay on track 3, so it's going to be a second. I just want to show you really quick, we still don't have that default. As soon as track 3 comes up, oh, it just came up, do show IP route, boom. Here's our static default route that was placed in the routing table, telling us that all traffic is going to go out to 10.0.14.1. Out gigabit 0/0. So now I should be able to, well, I have 8.8.8.8 and 4.2.2.2 for the ICMP. Well, I guess it doesn't matter. I mean, I can, obviously they're getting out to the internet because the tracking object went up, but I wanted to show you just kind of a test to show you that we do have internet connectivity. So I'll go ping, I'll do like one of Open DNS servers, one of Open DNS's DNS servers. So do ping 208.67.222.222. Okay. All right, so let's configure ISP2, which is on gig 0/1, which is really simple. Do a no shutdown and IP address DHCP. That's all you have to do. It's going to obtain an IP address via DHCP, and the magic is really what we just configured just a moment ago. So that's not going to come into play in the routing table unless this goes down. And I'll show you really quick by unplugging the cable what happens. And now even though track 3 is still up, we didn't have to wait out that delay because the interface is now down. So, but do you see that? As soon as we pull that, now we have a default route going out via 10.0.50.4, and that's that administrative distance I was talking about of 254. So now, if we go do ping 208.67.222.222, we have internet connectivity via ISP2. Okay, but we're not finished yet. Well, it really all depends on how long you want to watch this video. If that's all you wanted to know, then you're pretty much all set. We still have NAT to worry about, and if we wanted to configure a LAN side of the router in a DHCP pool on the router. So that's something I'm not going to go too much in depth with because that's not really entirely what this video is about. So I'm just going to kind of bang out the configuration really quick. But if anybody's interested in seeing how this is done, feel free to stick around and watch me set it up. So we have two interfaces, primary and the secondary. So ISP1, ISP2. We need to configure NAT, and we need to attach a route map to the NAT configuration. So so that way, the router knows what address pool or what interface to translate the private RFC 1918 addresses to when they go out. So you can't have addresses from, say you have Spectrum and Comcast. You can't have Spectrum addresses going out to Comcast or Comcast addresses going out to Spectrum. So we definitely need to create a policy in NAT to basically say, hey, if you're going out the Spectrum interface, NAT it to this. If you're going out the Comcast interface, NAT it to that, because the other provider will most likely, they'll have a firewall or something like that, or access control list on their end. They'll block those addresses, and it won't work that way. It's not like when you run, like the way the internet really is when you're running BGP with multiple providers. You could actually probably get away with routing addresses through another provider that they're not actually advertised to, because in that scenario, when you're running BGP, you own your own addresses and you advertise them using BGP. That's a totally different scenario. Not what this video is about at all. So anyways, I need to quit talking and just get on with the NAT configuration. So we'll go gig 0/0. That will be IPNAT outside, gig 0/1, IPNAT outside. And then we'll say that gig 0/2 is going to be our LAN interface, where we'll have a switch. We'll have a switch connected to gig 0/2. So that'll be IPNAT inside. All right, and then let's go. Let's say that our internal address range is going to be a private class C address. So I'll go IP access list extended NAT, and then I'll say permit IP 192.168.1.0. This will be our internal subnet. A wildcard mask of 000.255 to any. Okay, now let's create our first route map. So that will be, I'll name it NAT ISP1. Okay, so we'll match IP address NAT. So it will only NAT addresses that are sourced from our subnet that we defined in this access control list. So the 192.168.1.0/24 subnet. And then match interface gigabit 0/0. Because remember, gigabit 0/0 is the primary ISP. All right, so now we'll go route map NAT ISP2. We're going to match the same access list, except we're going to match interface gig 0/1. Okay, now that you've created the route maps, the next step is to add them into your NAT statement. So we'll go IPNAT inside source route map, and then we'll go NAT ISP1. And then we'll specify, now here you can specify an interface or a pool. In this case, we're going to specify an interface, and we are going to translate private addresses to the same address that sits on ISP1's gig 0/0 interface. And of course, don't forget the overload command. So we'll do port address translation. All right, and then same thing for ISP2, except that's on gig 0/1. So we want to overload those private addresses to the address that sits on gig 0/1 for ISP2. So we'll change the route map. So IPNet inside source route map, NAT ISP2, NAT it to interface gig 0/1 overload. All right, so let's configure gig 0/2, which will be our LAN interface. And I'll assign an address of 192.168.1.1/24 subnet mask, no shutdown. I think we already did the IPNet inside. We did. Okay, and then what I'm going to do is, after I configure the DHCP pool here, I'm going to actually plug into port or interface gig 0/2 on the router, see if I obtain an IP address, and see if I have internet connectivity, and then test failover. Okay, so let's just create a really simple DHCP pool. So IP DHCP pool, I'll just put LAN. The network is 192.168. What do we have going on here? Finish processing. Okay. 192.168 1.0/24. And I forgot my dot. Okay. Default router will be 192.168 1.1. And then DNS, I'll specify 1.1.1.1, 8.8.8.8 is backup. Okay, so we should be set. So we're going to plug in. Let me just make sure if I okay, if I unplug this from the network, I'm not going to disrupt any communication that is needed for this video. I hope. Let's try it. Okay. All right, so let's take this cable right here, and I'm going to plug it into the computer I'm on right now. I'm going to scoot my chair back and plug the other end into gig 0/2 on the router that we're on. Okay, line protocol on gig 0/2 changed to up. This looks promising. Let's go into command prompt, do an ipconfig, and we have an address, ipconfig/all. Yep, there's our DNS servers. Let's see if we can get out to the internet. Just looking for one thing. Okay, 1.2. So if there's ever a scenario where you want to avoid certain addresses being allocated from the DHCP pool, you would go IP DHCP. It already knows not to do the 1.1 because that was set as the default gateway. So we would go IP DHCP excluded address, and then you put your address ranges there. All right, so let's see if we have simple communication out to the internet. So I'll ping Google. Nice. Let's open this, and we'll go to google.com. Speedtest.net. Perfect. Okay. So the last thing is we're going to test failover. I'm trying to think of the best way to do this because, as you know, I mentioned the fact that this is plugged. These cables simulating the two different ISPs are plugged into my LAN core switch on different VLAN. So there's really no way for me to simulate an ISP failure except pulling the cable. So which it really isn't a, you know, I mean, I guess that's a failure, but it's not like a, you know, ISP1 actually went down. So I guess what I could do is I could, I guess I could get rid of the IPSLA probes for track 1 and 2. I guess that will simulate a lack of reachability, which will make track 3 go down. We'll fail over to ISP2. So let me try that. So I'll go no IPSLA 1 or 2. Should be going down, down, down. And then we still have that 20 seconds to wait out. Make sure that it's actually down. So in the meantime, we will still have the primary route out gig 0/0. No, oh, it must have just... Oh, no, of course it's still going to work because I just... ISP1 actually isn't down. I just deleted the... tracking objects. Okay, or the IPSLA monitor. All right, so here we go. We failed over to ISP2. We see that our new default is out to 10.050.4, and we should still be good to go. All right, and that is how you configure redundant ISP connections, residential ISP connections using a Cisco router. Thanks for watching this video. I really hope you learned something. And if you have any questions, please don't hesitate to reach out. You can leave a comment in the comment section below. You can use the contact form on my website, which is rmtechcentral.com, or you can send me an email to rob@rmtechcentral.com. Again, thanks for watching, and I'll see you in the next video.